Anyone has any question, then just let me know.
Sir, is there any exact procedure to find that intermediate compound, like when in the reverse reaction the right hand side compound and in the next intermediate reaction the left hand side, so there's a common compound, right, which is the intermediate. So
Yes.
is there any fixed method to find it, or we have to analyze how will we get the solution and what needs to be the intermediate?
Just I told you that if suppose you know the product, then you know the intermediate, right? And the second, there are two things which you need to keep in mind. What is the product in the one step prior to the rate determining step, and in the second step, what is the composition of atoms? Okay, and then certainly you need to also think of, you cannot think of some means like that whether for example carbon should be attached with four groups, right?
Yes.
uh, so those things you have to chemical insight which you already have, that you have to certainly apply. You cannot just write any structure, any compound, right? If you do that, then I think that you will be able to do it. Okay.
Okay.
And last thing what people do generally is once they come up with the intermediate, then they also try to look at that intermediate. If intermediates can also be characterized. So after they propose a mechanism, generally they go for looking at finding whether that intermediate is involved or not, and then you can know just by some spectroscopic technique whether that exists or not. Again, suppose carbocation is involved, then you know that if I change the solvent, right, then that should increase the rate of reaction. So those ideas which you have already got from kinetics, that can be utilized to confirm the presence of that intermediate. Okay.
Okay, sir.
Okay. So let me go ahead and then let's discuss. Okay. So we started with, I gave the in the last class this example, I minus plus OCl minus, giving you IO minus plus Cl minus, right? And then rate was given is equal to K is 2, and then I minus OCl minus divided by OH minus. Okay. Now you see that OH minus is not a reactant. It is also not a product, but it is not a reactant. Certainly, it must have formed in one of the state, and then it also may get cancelled out. So, uh, so since there is one species in the denominator, so step will not be a single step. Okay, although there are not two terms, but you can understand this, that this cannot come with reaction is one step process. So at least there should be two steps. So again, the same way we can go ahead. All right. This OH minus is in the denominator, so OH minus will be must have formed in the one step prior to rate determining step. Now let's look at the composition. There is some I here, intermediate, and this I is involved here. Okay. Now let us think about what is the composition of RDS. So composition of RDS. Before that, just look at this. This is OH minus, right? So there is one hydrogen at this place, right? And if you go to this overall reaction, there is no H. So tell me from where it will come.
Water.
Then H2O.
H2. Very good. So water. And there is a reactant here. So it is quite obvious that this hydrogen must have come from water. Now, let's look at the composition of RDS. How many I? 1. Then oxygen.
0.
क्या होगा?
0.
And then what? Chlorine.
1. 1.
Okay. And now you can think of और क्या हो सकता है? यहाँ OH माइनस है तो ऊपर क्या होना चाहिए? I believe.
H plus.
H2O होगा तभी होगा, हमारे H का कैसे आप in the account लोगे? There must be H2O here. Then only I can take into account this H. Right? Then oxygen कितना हुआ आप just बताओ?
1.
In fact, this will not be a product. Let me just 1 minute. OH minus may be intermediate also. So keep that thing in. So here there can be a product or intermediate. And this OH minus can also be an intermediate. It must be intermediate because, it is not involved in this reaction. So OH minus must be an intermediate. So let's write OH minus here. So just 1 minute. No, that's okay. Product or intermediate you can write here. So tell me what can happen. I is 1, oxygen is 1, hydrogen is what now we can write. एक H2O होना चाहिए ना?
1 hydrogen.
So again go back here. This hydrogen we cannot take into account. ये तो negative नहीं हो सकता ना? Hydrogen number if you calculate from this, hydrogen cannot be negative. Am I right?
Yes.
Okay. So क्या होगा यहाँ पे? H2O होना चाहिए. Now let's calculate what should be I? Number
1.
of I? 1.
Yes.
What about oxygen?
1.
1. What about chlorine?
1.
1. What about hydrogen?
1.
1. And then charge. Tell me charge.
-1.
Minus?
1.
Minus 1. Charge is -1. Am I right? Charge is -1. So this is plus H2O I plus OH minus I plus. Okay? That's what we have to write. There must be a reactant here. So OH minus, so let us see. So I is 1, O is 1, 1. OH minus ion. Tell me what should be the reactant here? So that you can get
OCl
OH
minus.
minus ion.
OCl minus.
OCl minus. So write OCl minus. So what will be the intermediate?
HOCl.
HOCl. Okay. So what should be here?
But OCl minus would be the reactant.
OCl minus you see reactant. Alright.
So ऊपर तो ठीक है, but यहाँ पर हमने OCl.
यहाँ OCl minus होगा ना? Plus H2O.
Okay, so ठीक है.
Alright.
I माइनस भी तो हो सकता है, मतलब वो भी तो रिएक्टेंट ही है.
Yeah. I minus भी हो सकता है. We will see that. Okay. We can see that. So let's start with OCl minus and we can think about I minus also. If suppose this is the thing, HOCl is there, you have one H, you have one O, one Cl. What is left? I
I.
minus is also reactant, and this I is your HOCl. So what is the product now? Is this goes with what we have derived?
Yes, sir.
जा सकता है, am I right? So let's think what I will get here. HOI plus
Cl minus.
So mechanism हो गया. Now here he was saying let's start with I minus. I minus plus H2O. And what you are saying is I should get what? HI plus OH minus. Am I right? Is this okay?
Yeah.
Then HI is the this thing. अब देखो एक H हो गया एक I हो गया. Am I right? Then what is this?
OCl minus.
OCl minus. OCl minus. ये भी लिख सकते हैं. What we will get here? HOCl क्या मिलेगा बताओ? HOCl मिलेगा and plus I minus. Now sum this और इस दोनों को which corresponds to this one. इसमें क्या प्रोडक्ट बना? HI cancel. Am I right?
Yes.
So what is the product?
HOCl plus.
HOCl.
Yes, sir. And OH minus.
हाँ plus I minus.
I minus cancel.
I minus है यहाँ पे. तो I minus cancels out.
Yes.
ये हो सकता है बताओ. I minus cancels out. तो क्या होगा तुम्हारा?
तो you can say गलत है मतलब.
So final reaction में I minus नहीं होगा फिर.
दूसरा क्या सोच सकते हो यहाँ पे HCl plus IO minus. That you can also think of.
Yes.
HCl plus IO minus. You have to see also overall reaction which matches with this. And again I told you that you can end up with the two unique mechanisms. There is no problem in that. Always it is not true that just by looking at the rate of reaction or rate law, we can arrive at only one particular mechanism. That is not true. What I told that you know you can get out of 1,000 mechanisms which you can think of, you can pinpoint 2 or 3 of them which goes with the rate law. So that is very important to understand. I'm not first ruling it out. You can think in a different way. Maybe one of them will also agree with this. Okay, but that's okay. You may end up with two mechanisms. And then you have to find out which one is right In that case, for example, HOCl is getting formed. Here HI is getting formed. If there is some, mechanism, something, because this will certainly, this is not true, right? HOCl will not form.
Yes, sir.
So how are we sure that OH minus was not intermediate? That also we only go by trial and error.
Yeah. So in fact, if you look at this, OH minus is in this one. Am I right?
Yes, sir.
Okay. You can think of this as intermediate, but generally intermediate doesn't come here. Am I right?
Yes, sir. Exactly.
So intermediate will never be it means that this is a product of the reaction. Certainly this is not reactant, but this can be product. Am I right? So this will be a product because you have not started with OH minus ion. Okay, you have not started with OH minus ion. And since we are retaining the ionic term, so you are looking at this. But if you balance, taking everything into account, HI plus HOCl, something like that, then NaCl, then you will see that OH minus will also come into picture. But important thing is OH minus is in denominator. OH minus is not as a reactant. It must have come from the solvent. Am I right? OH minus must have come from the solvent. If it has come from the solvent, it is a product. And that's why we are writing it as a product. Intermediate never comes as in the denominator. Is this okay? Should we explain again one more time? You want me to do that? Or is this okay?
Sir, so we can say that OH minus came from the solvent, that's why it's a product, or because it can't be intermediate, that's why it's a product.
Both things are important. Keep
Okay.
that thing in mind. If OH minus is a reactant, then certainly it would have involved here. It is not a reactant. Otherwise, you will write it here.
Yes.
Right? And this cannot be intermediate. First, I am ruling out that this is not an intermediate. This is not an reactant. Then second logic I am putting to tell you that this is not an intermediate. Okay, so there are two logics behind it. That gives you idea that this is a product. Right? If you write H2O, then certainly you will get here OH minus. Okay, so keep this thing in mind. Then somewhat the okay. Can you listen me? Hello?
Yes, sir.
Okay. So let us go and let me introduce one more concept. That is, I write this and then I will see the application. If the rate law has the factor B half. Okay, this laws you can find out. Okay, this is given in expansion law. All right, but example you will not be able to find out. But this laws you can find out. I have already given the name of the book to you in the first lecture. So if you want to look at the laws, you can see that. But how it has come, it has not been written. But I discussed you that how these laws has come. Okay, so what does this say? That if the rate law has the factor b half, so any fractional term which you see in the rate law, the mechanism probably involves splitting a B molecule into two species before the rate limiting state. So there must be a splitting of a molecule, a same molecule which has this order equal to fraction. Okay. For example, if Br2 breaks into 2Br, then you will find this kind of term. And I will give you one example. So let us think about this mechanism. And you can see that this is a very complex mechanism, but just by looking at the rate law, probably you will be able to tell. Okay. So this is the reaction H2 plus Br2, and this is in presence of light gives you 2HBr. 2HBr. Okay, and then half dHBr by dt, this experimentally this has been obtained, is equal to K Br2 half H2 1 plus K dash HBr by Br2. In fact, just to make sure that you understand what does that mean, I can also write like this. Br2 3 by 2 S2 divided by Br2 plus K dash HBr. Now find out the mechanism. खुद try करो, सोचो. Yes. So say try करो. It is very important for you to try.
Sir, can you please show the previous slide again?
Is this okay? Can I change? Are you able to do? Hello, can you listen?
If you can listen.
Am I audible?
Yes,
Okay.
sir.
Okay. हो पाया या नहीं हो पाया?
तो थोड़ी दिक्कत हो रही है एक जगह.
दिक्कत हो रही है. सोचो, just simply take this. Let me now explain. Okay. So this is yes. This is the reaction. Am I right? S2 plus Br2 to HBr. HBr. First thing you look at this point. So there should be at least 2 steps. So first I will start like this. कुछ करना नहीं है. Now tell me which one is the product in this 2?
HBr is
HBr. यहाँ पे क्या होना चाहिए?
Br.
ये तो ठीक है? Okay. Now tell me what is the composition here? क्या होना चाहिए? Just take from this. Br2 neglect करते हैं because RDS का हम ले रहे हैं. So just neglect this Br2. What is the composition of reactant in RDS?
Half Br.
RDS. How many Br?
Half.
Br2 half हो गया ना? This is Br power 3, right? And this is Br. So 2 Br, right? What about H? 1. तो अब बताओ Br2 ऑलरेडी है, यहाँ क्या होगा? यहाँ क्या होगा बताओ? 2 Br तो ऑलरेडी है, बचा क्या?
H2.
1 H?
Yes.
There is 1 H. ये किससे बना होगा? और पहला, इसके पहले मैंने बोला है कि स्प्लिटिंग होना चाहिए. इसी से Br आया होगा. Am I right?
Yes.
Now tell me what you will get here.
HBr plus Br.
HBr plus Br. Now combine this, what you will get?
Sir, in the last step, there should be 2 Br. H plus 2 Br.
हाँ, होगा ना? That will come later. First tell me what is the, if I combine these two, what I will get? एक Br cancel.
H is okay.
Right? 2 Br2. H cancel.
Yes.
So what I will get? S2 plus 2 Br2. Huh? What I will get this side? 2 HBr. How many Br?
So
2 Br. अब बताओ तो एक स्टेप क्या बचा? यहाँ क्या होना चाहिए? This is not the product, or there is only Br here. So can I write here this 2 Br goes to Br2?
Yes.
हो गया? Complete. So there is only 1 HBr left, and this goes out. देखा 4 step में you are able to write this whole mechanism. I don't do anything. I just took the rate law, and we are able to see that what can be the mechanism. So even for complex processes, you can write a mechanism. Of course, then you go for looking at whether Br free radical has formed or not. That you can see. There are ways to look at it. But initially you can get one mechanism from the rate law. Not one, more than one, but certainly out of 1,000 or whatever you can think of, out of so many options, you can bring it down to 1, 2 options. Is this okay? Does this make sense?
Yes, sir.
Yes, sir.
फिर से
Sir,
करके
here,
दिखाऊं मैं?
sir, I have a doubt here. H is without any charge.
It is free radical. This is, this happens in presence of light.
Okay.
Okay, this is homolytic fission. पढ़ा है ना free radical?
Yes, sir.
I have not shown this, but you can simply write like Br dot. This is the way free radical is written, but in physical chemistry we don't show that. Okay, but once you see H, you mean that it is free radical. H free radical, Br free radical, and that always forms when you are dealing with a photochemical reaction.
Okay.
Is this okay? And do you want me to explain one more time? कुछ नहीं है, Let me again go one more time because this is very important. क्या था rate law? Is R was given as K Br2 half S2 divided by 1 plus K dash HBr by so let's write like this Br2 I'm trying to write because this is Br2 and this is Br2 3 by 2 plus K dash HBr. Okay, so this is the rate law. Two equations, two concentration term in the denominator, it means there is two steps. One is reversible and the second is this. Okay, this is reactant, so this must be involved here. And this is product, and so this must have formed in prior to this step. Okay, assume that this is rate determining, then you are neglecting this. And this is rate determining, then now I can get the composition of this. What is the composition that you can get from this? Br 2 into 3 by T, 2 means 2 cancels out, 3 Br here, 1 Br minus, then Br is 2. There are 2 H here, 1 H remove, so you are getting 1 H. Already 2 Br has been is involved in this RDS, so what is left is H. So this H must have formed here. Right, and this can only come from this reaction S2 plus Br. And Br, again, that also goes according to our thinking that Br2 must have a split prior to these steps. So Br2 going to 2Br. And this will certainly give you HBr plus H. Okay, H plus Br2, HBr plus H. And then you see that if you try to balance to get the overall reaction, you will get this system, Br2 to 2Br. Sorry. Okay. 2Br going to Br2. Am I right? 2Br going to Br2. And that is also quite obvious that last step should be termination step. And if you do this balance, then you will get S2 plus Br2 to H. And that's what you should get at the end of the end of the writing mechanism. The whole the combination of state will give reaction corresponding to overall reaction. So this is the way. So you now see that we have derived 4 steps. Till now we are focusing on 2 steps only, but now you can write 4 steps. Okay? Is this okay?
Yes.
Okay. So now let us go and see a few more things before moving to the next topic. Okay, so there are a few things which generally we don't use, but this can also be used in certain cases. Okay, the order decreases with increasing concentration when the reaction happens in the series of steps. Okay, so order decreases with increasing concentration when the reaction happens in series of steps. So for example, this is the whole reaction, Fe2 plus Tl3 plus Fe3 plus Tl2 plus. Let me again come back. Okay, so the order decreases with increasing concentration when the reaction happens in series of steps. So this is the reaction mechanism, Fe2 plus Tl3 plus giving you Fe3 plus Tl2 plus. Then Fe2 plus Tl2 plus uh, Tl2 plus, this is intermediate here, Tl2 plus giving you Fe3 plus and plus Tl plus. So what you will get is this reaction mechanism. Okay, you can see that Fe2 plus is the reactant here and Tl2 plus is intermediate, Fe3 plus is product, and so there is one product term here. You can even write down this yourself. Right? If this is the mechanism, what is the rate law? So this is the rate law. Okay. So the order decreases with increasing concentration when the reaction happens in series of steps. Now think about this, that if Fe2 plus, which is a reactant, is negligible. So in that case, okay, so this is Fe, yeah. Negligible, then order with respect to Fe2 plus will be what? This is, since RDS, this is already negligible. Okay. So if Fe2 plus is small in amount, what will the order with respect to Fe?
But Fe2 plus is RDS, right? Not Fe3.
Fe2 plus is reactant, right? Oh, okay. You are right. Yeah. Fe2 plus. Okay. You are right that Fe2 plus will be. Okay, so we are just thinking in terms of order with respect to Fe2 plus. What is the order with respect to Fe2 plus? Suppose I cannot neglect this. Okay, then what should be the order?
1. If you can't make.
If you can, if you increase this to higher amount, then what will be the order? 1. And if it is a small amount, then order will be 2.
2.
Right? That's
Yes.
what it means by this. So order decreases with increasing concentration and reaction happens in series of steps. And that is quite obvious. Any reactant, if it is reacting with intermediate, it will come in the denominator. And if I increase the concentration of this reactant, then what will happen? The order will start decreasing with it increase in the concentration, because now this is in the denominator, right? So from that it has come that order decreases with increasing concentration when reaction happens in series of steps. In fact, you can do write in a different way, that if Fe2 plus of or any reactant is involved in reaction with intermediate, then this will happen. Order will decrease with increasing concentration of that reactant. Okay. Then next thing is rate. The number of positive terms in the rate law is the number of independent parallel pathways that we have already discussed. So A plus B giving you C plus P. This is a product. C plus R2 gives you R2 is reactant again. This is P2. C plus R3 gives you P3. Then this P, R2 and R3 will be in the denominator. So number of positive terms in the rate law is the, okay, so no, so this is a different thing. Number of positive terms in the rate law is the number of independent parallel pathway. Independent parallel pathway. We are talking now numerator. So if there are two positive terms, so this is sum of two terms. If there are sum of two terms, it means there will be independent parallel pathway will be 2. Okay, independent parallel pathway will be 2.
So why is it independent parallel? Like both depend on R2 and C and R3 and C, right? Independent with respect to what?
Independent means this is not independent. This is independent. These are the independent pathway. All right. So means C is reacting with, this is parallel. All right. C going to R2, C reacting with R2 to give P2, and C reacting with R3 to give P3. Okay. So this
Parallel
is parallel pathway, and that's why there are two terms here. Is this okay?
Sir, independent वाला part मतलब confirm कर रहा हूँ. Like independent because it's not a part of the main equation like that.
It is not the part of where main reactant has involved.
Okay.
Okay. Order increases with this thing we have already seen. Order decreases with increasing concentration, but the order increases with increasing concentration when reaction proceeds through parallel pathway. ये क्या लिखा था हमने? If you remember, this is for sequential reaction. The order decreases with increasing concentration. यहाँ पे हम क्या कर रहे हैं? Order increases with increasing concentration when the reaction proceeds through parallel pathway. So for example, this is one of the reaction. Its rate law is given by this. In this, H plus is involved. Okay. So if H plus is small, then this term goes away. Am I right? So what is the order with respect to H plus? If H plus is small, this term is very small. And so this can be neglected. So order with respect to H plus is 0.
Yes.
As if, and if you see H plus is high, then this term can be neglected. And then order is 1 with respect to H plus. Certainly I am talking about H plus. And this can only happen when reaction proceeds through parallel pathway. Okay. So please keep those things in mind. So these are the different rules which we discussed when I gave you for the first time the list of rules. And this gives you a bit of, whenever you are trying to write a mechanism, if you keep this thing in mind, then, you understand that it will be easy for you to write the whole mechanism. Okay. And sometimes people do this kind of experiment to know that whether there is parallel pathway or not, or if there is a sequential reaction. Okay, sequential reaction is involved or not.
So in the previous one, it is not mentioned that the positive terms are in the numerator, like in the previous rule which you gave. So is it understood that it will only be counted in the numerator?
So already I have taught about if there is more than if there are terms in the denominator.
Yes,
Here we are talking, this rule is only to give you idea if there are more than one positive term in the numerator. Till now we are discussing, till now I have discussed only numerator term, denominator term. Now I discuss the numerator term. Okay, so please keep this thing in mind. Maybe you are not, you may not need this because this is enough. The rule about the terms in denominator is enough to give you mechanism. Okay, but sometimes this may be needed, or this may be a kind of extra tool for you to verify your mechanism. Okay, now you can derive this. We have already done in the last class. You will get this thing. In fact, the kind of calculation we have done to get the rate of reaction, that will be enough to for you to write what should be the rate law, isn't it? So you can know just by looking at it that there should be 3 different terms in the denominator. Is this okay?
Yes, sir.
Okay. Now let me go to give one more example. Enzyme catalysis. Okay. Have you heard about enzyme catalysis?
So lock and key mechanism, that one or?
Okay. So enzymes are catalysts, am I right?
Yes, sir.
Okay. So that increases rate of reactions. So people try to know what can be the mechanism. So first, to look at rate law, how people determine rate law. What they got, at low substrate concentration. So this is your reaction, E plus S, right? This is the reaction. It goes to product, final is product, plus enzyme comes out because it is a catalyst. All right. So this is kind of reaction. So at low substrate concentration, the rate is first order in both E and S. That's what people came to know just by experiment. At low substrate concentration, if I increase the initial enzyme concentration, rate will increase. If I increase substrate concentration, rate will increase. Okay, it is quite simple, and the increase is first order with respect to E and first order with respect to S. So at high substrate concentration, this is the first observation. The second observation, at high substrate concentration, rate is independent of substrate concentration. What does that mean? It is independent of this substrate, but again first order with respect to enzyme. Now you can simply write what can be the rate. Rate will be given by this. Right? There should be a substrate concentration in the denominator. If suppose I neglect this, then that can happen when you are dealing with low substrate concentration. So you can neglect this part. So now rate of reaction is first order with respect to enzyme, first order with respect to substrate. But at high substrate concentration, this K dash can be neglected. And then it is first order with respect to enzyme, but S0 cancels out. So zero order with respect to substrate. So this is the rate law. And from the rate law, now you know that this should be at least two-step mechanism. Two-step mechanism. Am I right?
Yes, sir.
So just by looking at this rate law, and why I am giving this experimental observation, because the way we write rate law is looking at this kind of experimental observations. So if now this is the rate law, what should be the mechanism? And based on this, Michaels and Minton proposed the mechanism of enzyme action based on the rate law. And enzyme kinetics is one of the very important tool to study enzymes. Okay, so think about what can be the mechanism. We will discuss in the next lecture. Or I may also wait till I introduce catalysis. Okay, is there any questions? Please let me know if you have any question. No one? Pritam, do you have any question?
No, sir.
Okay. Purvi?
No, sir.
Okay, so I will stop here. Again, I will tell you guys that if you have any question, you can write to me through email. Okay. If you really want some more time, then I can arrange one-to-one meeting on Microsoft Teams. So feel free to write to me, so that this mechanism part is very important. And this is one of the very important application of kinetics. Okay? No question? Then yeah. No question, then I will leave.
Thank you, sir.
Thank you, sir.